Hi there. My name is Mr. Barrick. If I haven't met you before, I teach science at Durham. My students have seen my face before, but you might not have seen mine. I'm working with Miss Graham and Miss Hartramp this fall. I've taught quite a bit, but this is my first year at Durham. My job today, we all have jobs. You know, that's the cool thing about working in the science department. Everybody does something. Well, my job today is to go over the last assessment you took and to kind of share with you how a lot of 8th and ninth grade students might have looked at it. Okay, so I'm just going to share some things as we go. Question number 1. Get this into view here. What has mass and volume? Well, what I've tried to coach up my kids to do, my students to do over the last 45 years is to, when you get a question like that, think about the answer before you look at your choices, or what they call the foils. What has mass and volume? Matter has mass and volume, and there it is, number 4, or D, I guess, matter. Number 2, now you can just glance at the answers if you want. Don't get me wrong, that's fine. And you can go fast forward through this, or you can listen to maybe some suggestions. Physical properties can be observed and or measured. Physical properties can be observed and or measured without changing the substance's what. So when I look at a metal bar, when I look at a piece of fruit, whatever it might be, when I'm looking at their physical properties without changing the substance's chemical makeup, the substance doesn't change. When I'm looking at it, when I'm measuring its density, when I'm seeing if it's malleable, if I'm boiling it, if I'm melting it, I'm not changing its chemical makeup. Number 3. Which of the following properties of ethanol is a chemical property? Well, you might not know what ethanol is. Put anything else in there you want. Put gasoline in there, put milk in there, put water in there. It doesn't matter what it is. Chemical properties are chemical properties. So let's look at this list down below and see which one of these is a chemical property. And colorless is a physical property. And boils at 78 degrees is a physical property. And density is a physical property. Flammability, that's a chemical property. Number 4. A student is conducting an investigation to determine the identity of an unknown substance. The following data was collected. The substance is yellow. That's a physical property. The substance melts at 273 degrees Celsius. Wow, that's high. I mean, a candy bar, I know it's a candy bar. A candy bar melts in your pocket. Gosh, what is that? About 30 degrees? I'm going to have to check that. I can't remember what body temperature is on Celsius. I should know many times I've had my temperature taken, but that's pretty warm. But that's a physical property. When placed in water, the substance floats. That's density, and that means it has a density less than 1. When in the presence of a flame, the substance does not burn. Okay, now it does not burn. So some people say, well, that's not a chemical property. Yeah, the fact that it doesn't burn, that's a chemical property. Okay, it could be anything. When the substance is added to hydrochloric acid, a gas forms and a temperature change occurs. That's a chemical property as well. So I'm not sure what I'm doing here, but the 1, 2, 3 are physical, and 4 and 5 are chemical. So let's look what the question is. So the best answer is not for number 4 is 1, 2, and 3. And I get it now when some of my students said, because I don't see it on there either, where's the question at? So yeah, 1, 2, and 3 are the physical properties. Number 5, which of these is a chemical property of a sheet of paper? Chemical property, sheet of paper. The paper can be crumpled. That's a physical property. Paper can be burned. That's a chemical property. The paper is not magnetic. Physical property. The paper has a smooth texture. Physical property. So as it's checked, the best answer is number 2. Number 6, silver is a white metal that is an excellent conductor of heat and electricity. Silver tarnishes. Tarnish means when you when you get it out in the, on a table or it warms up, it combines with oxygen. You get that little film on it. That's chemical. The density of silver is 10.49 grams. That means it's heavy. It's a very dense material. Gold is a little bit more dense, but those definitely will sink in water. The melting point is 962 degrees Celsius. I thought the one up above was hot. It takes a lot to melt it. And the boiling point, where it turns from a liquid to a gas, and it will, is 2,000 degrees Celsius. It won't in my kitchen, but there are ovens or pieces of equipment that can heat silver to the point that it would change from a liquid to a gas. Which of these characteristics is a chemical property of silver? Well, I talked about the fact that it tarnishes. It combines with oxygen. Silver tarnishing. Number 7. Okay, now I'm going to eyeball this a little bit before we look down at the question. So this atom, the filled in ones, 1, 2, 3, 4, 5, 6. It's got 6 protons. It has 1, 2, 3, 4, 5, 6 neutrons. Should have 6 electrons. Okay, 6, 6, 6, 6, 6. It's got a whole bunch of 6s in it. Which element is represented by the model of the atomic of the atom above? Well, it's carbon. Carbon has an atomic number of 6, and in 12.01 rounds down to 12. So it has an atomic mass number of 12, so it has 6 neutrons. So wow, best answer is A. Number 8. Which part of the atom cannot have its location accurately determined and is modeled by a cloud around the center of the atom? So, we've talked about electrons being in these orbits, but that's just the model that works for us. What electrons really are these subatomic particles that go flying around all the time. But at any one time, if it has 2 or more electrons, 2 of them are going to be pretty close to the nucleus of the atom, but they're in that cloud. So the best answer for 8 is A, electron. They're in an electron cloud. Boy, when you see the word cloud, yeah, you ought to figure out that that is definitely an electron we're talking about. Number 9, an atom of gold with 79 protons. That's pretty heavy. And 118 neutrons would have how many electrons? Well, now, come on, guys. They're just trying to throw you off. 118 neutrons doesn't have anything to do with how many electrons it's going to have. It's got 79 protons. It's going to have 79 electrons. Protons in a neutral atom equals the number of electrons. We got this. Number 10. Where are electrons located in an atom? Well, they're not in the nucleus, okay? And then look at some of these foils on here with the quarks. Well, quarks is a concept that we're going to use when we look at the inside of subatomic particles, but that's not the answer. With the neutrons, well, no, neutrons are inside of the nucleus, and we know electrons are not inside the nucleus. Near the protons, that's the 4th one. No, they're not near the protons. They're outside the nucleus. Number 11. Ooh, I get to look at a chart first. The table shows some characteristics of a few atoms. So carbon has an atomic number 6, and then it has 6 something. It's not telling us what it is. And then it has an atomic mass of 12. And then it has an atomic number, the chromium has an atomic number of 24. So when you look at it on a chart, it's number 24. And it's got how many number of something? 28. And it's got a mass of 52. Well, I'm starting to gather that this column right here is the number of neutrons. The mass of the element is the sum of the atomic number, and so the mass of the element is the atomic number plus the number of neutrons. Boom, neutrons, D. So let's get, what are we supposed to know from this? We're supposed to know that atomic mass is the number of protons plus the number of neutrons, okay? Number 12. Which particle always has a mass of 1 atomic mass unit and no charge? Well, boy, it's nice that they told us that it has an atomic mass unit, 1, but when it said no charge, we know that has to be a neutron. Okay, no charge, neutron, neutral. Number 13. What are the parts that make up an atom? Well, right off the bat in the first answer, you see electrons, neutrons, and protons, but you don't see anything about the nucleus. So that's because there really isn't any. The nucleus is an area. You don't live in Ackworth. You don't live in Kennesaw. You live in a house. Ackworth and Kennesaw is just like an area, and so is the nucleus of an atom. The nucleus of an atom is just an area where electrons, neutrons, where neutrons and protons hang out. And electrons are those things that spin around it. But the physical parts of an atom are electrons, neutrons, and protons. These things down here below, they're all real things. They're just not a makeup of the atom as we look at it. Number 14, an atom's mass number is 210. Okay, that's the number of protons and neutrons. And its atomic number is 85. How many neutrons does the atom have? Now look, I'd really like you to do the math. I'd really like you to subtract 210 minus 85, and I want you to get 125. But come on, let's look at these answers. Let's just estimate 21 minus 8 is 13. Okay, now obviously I rounded, or I cut off, whatever the phrase my math teacher friends would say, I'm estimating. So 21 minus 8 is 13, so that's really 130. Which of these are closest to 130? And that'd be 125. And that's without doing real math. But you can do real math. I know you can. Number 15. Oh, good. I get a big picture here. Let me see if I can make it a little bit smaller. And he can't. And I don't know why, and I apologize. So this is the nucleus of an atom plus the electrons. There's 2 electrons in the first shell, and there's 1, 2, 3, 4, 5. There's got to be more than that. Oh no, there's 2 on the inside. I got it. 2, and then 1, 2, 3, 4, 5 on the outside. So there's 7 protons and there's 7 electrons. Okay? And the question is, how many valence electrons does this atom have? How many electrons? I don't know if you saw me moving all over the screen. I've never done that before. How many valence electrons does this atom have? Well, what they're really saying is how many electrons are found in the outside shell. Okay, and there are 5. 1, 2, 3, 4, 5. I hope you can see those, and I apologize for not making it small enough for you to be able to see. All right, let's look at hydrogen. Hydrogen, this is a symbol for a square of hydrogen. It has an atomic number of 1. Its symbol is H, and it has an atomic mass of 1.0078. So if we were to round that, we would round that down to 1. So if it's got an atomic number of 1 and it has an atomic mass of 1, 1 minus 1 is 0, it's got 0 neutrons. Okay? What's the question? An atom of hydrogen consists of 1 proton surrounded by 1 electron, no neutrons. Let's see what we got down here. 1 proton, 1 neutron. That's the best answer. 1 proton, 1 neutron. 1 proton, 1 neutron. 17. At the center of every atom lies a small, dense blank that is positively charged. Well, the only thing in the atom, whether it's in the nucleus or the electron cloud or wherever, the only thing that's positive in an atom is in the nucleus, okay, and it's a proton. At the center of every atom lies a small, dense nucleus. And inside of that nucleus are the only positive things in an atom, and that would be a proton. So notice that protons are not the answer. Nucleus is. Nucleus is where that proton hangs out at. 18. What is the atomic number of the atom below? Okay, so I'm going right down here to the middle. I'm going right to this green part. I hope you can see this. It has 13 protons. So what's its atomic number? Its atomic number is going to be 13. Come on, you got this. 19. 20 is the blank of potassium. Well, here's potassium. You've heard of potassium before. You've seen the cereal Special K. It has an atomic number of 19. It has an atomic mass of 39.098. So if we want to find the atomic mass number, that would be 39. We want to find out the number of neutrons. Isn't that our question? No, 20 is the blank of potassium. So if we want to find the number of neutrons, 39 minus 19 is 20. Whoa. So the number of neutrons, 20 is the, and let's look down here, a number of neutrons in potassium. Gosh, guys, I'm so sorry you can't see the whole thing at the same time, but that's okay. So what's this question trying to find? It's trying to find out if you know how to find the number of neutrons in an atom. And you do that by finding the atomic mass number and then subtracting the number of protons. 39 minus 19 is 20. And finally, number 20. Oh, here we go. I gotta be able to do this. Let's see now here. Here we go. Look at me. Look at me. I finally got smart for the last question. Here's an element tab or a square for an element. It's boron, and it has an atomic number of 5 and it has an atomic mass of 10.81. Well, to find the atomic mass number, we're going to round up to 11. To find out the number of neutrons, 11 minus 5 is 6. Now, maybe we don't need all that work, but let's see what the question is. Oh, what was the question? How many electrons in an electrical neutral atom of boron? So if it has 5 protons, how many electrons does it have? 5. Boom. Okay, everybody got that? So what are you supposed to know? You're supposed to know that the number of electrons is equal to the number of protons. All right, I hope you've enjoyed this as much as I've enjoyed making it. Good luck on your assessment.